স্যার আমার মনে হয় আপনি এখন মানে শুরু করে দিতে পারেন।
Okay, fine. Thank you. Dear students, dear students of class 10E English version, I am Prashanta, Assistant Professor of Mathematics, Dhaka Residential Model College. You are welcome to higher math class. My class topic is coordinate geometry. At first, I will discuss all basic rules of each exercise, and then I will solve problems. I hope you are quite well, and I am also well by the blessings of Almighty. Please be attentive to my class. So please be ready with textbook, khata, and pens. Now I am going to start my class. Coordinate geometry. Coordinate geometry is the portion of mathematics in which
স্যার আপনি নিজেকে মিউট করে দিচ্ছেন।
স্যার আপনার ফোন থেকে আপনি একটু আনমিউট করেন। স্যার মিউট করেন।
আমি কি প্রথম থেকে শুরু করব?
না না স্যার, আপনি মানে কন্টিনিউ করেন স্যার। ওকে, এখন ঠিক আছে স্যার।
Coordinate geometry is classified into 4 exercises in your textbook. I will discuss each exercise one by one. Now I will say about coordinates of a point. Students, what is coordinates of a point? Coordinates of a point, mathematical representation of the position of a point with respect to some points or straight lines is called the coordinates of the point. Coordinates of a point is initiated by a great mathematician and philosopher, Rene Descartes. So it is named Descartes coordinate system. Now let us discuss about Descartes coordinates. Friends, Cartesian coordinates of a point. Cartesian coordinates of a point is represented by x, small. The first element x is called the axis of the point, and the small y is the coordinate of the point. Now let us draw it here. X prime x, y prime and O. Friends,
স্যার
horizontal
আপনার
line
ভিডিও বারবার আটকায় যাচ্ছে স্যার।
O y prime, the vertical line y o y prime is called y axis. Now let us take a point. Now let us take a point xy, and let us draw perpendicular from the point xy perpendicular to the y-axis, and this is x and this is y. Axis, we know x is the axis of the point xy. Abscissa of a point is the perpendicular distance from the y-axis, and ordinate of the point is the perpendicular distance from the x-axis. Now students, distance x1 unit. Students, dear students, distance between x1 y1 and x2 y2 equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square units. That is, if two points are totally different, that is their FCC and also ordinates are different, then we can find the distance between these 2 points by this formula. If the point x1 y1, distance between these 2 points are x1 y1 and x2 y1. Friends, here what is the difference? Can you say what is the difference between these 2 points? We can see coordinates are the same. Coordinates are the same, and FCC are different. In 2 points, if FCC are different and ordinates are the same, then the distance between them equal to modulus of x1 minus x2 units. Friends, please write these rules. Again, if the friends, what is the difference between these 2 points? What is the difference between these 2 points? These 2 points are different, but there is a dissimilarity between them. x1, that is FCC are the same, but ordinates are different. In this point, ordinate y1, and in that point, coordinate y2. In this case, the difference between the distance between 2 points equal to modulus of y1 minus y2. Modulus of y1 minus y2. Now, another formula, distance between 0, 0 and x1. Distance between 0, 0 and x1. 0, 0 is also known as the origin. Distance between 0, 0 and xy equal to square root of x squared plus y squared units. Distance between 0, 0 and x, distance between 0, 0 and x 0 or minus x is modulus of x. Students, we know the points x0 and minus x0 lie on the x-axis. x0, if x is positive, the point x0 lies on the positive direction of x-axis, and if x is positive, then minus x will be negative. So in this case, minus x0 lies on the negative direction of x-axis. So if we want to find the distance, the points x0 or minus x0 from the origin or 0, 0, then we can apply this rule. That is, the distance is modulus of x. And similarly, the distance between 0, 0 and 0 y 0 minus y equal to modulus of y. Friends, in these 2 points, lie on the y-axis. The point 0, y lie on the positive direction of y-axis. If y is positive, and the point 0 minus y lies on the negative direction of y-axis, because these 2 points lie on the y-axis because the FCC are 0. The students, the distance we have learned how to determine the distance between 2 points in Cartesian coordinates. Now I will discuss how to determine the middle point of a line segment. Friends, this is a line segment, and let us assume the coordinates of this point x1, y1, and the coordinates of that point is x2, y2. X2, y2. If we want, that is, the end points of this line segment are given. So how can we find the coordinates of the middle point of this line segment? The rule is okay. x1 plus x2 divided by 2 y1 plus y2 by 2. This is if this point the middle point of this line segment, then the coordinates of it x1 plus x2 by 2, y1 plus y2 by 2. Do you understand, friends? Any problem? Please be quiet and listen to me. Students, I am going to discuss if the vertices of 3 points are given, that is, if the vertices of a triangle are given, how to determine it is an equilateral triangle and it is an isosceles triangle. Now I am going to discuss them. That is x1, y1, b, x2, y2, and c, x, c, y. Let us suppose these are 3 points in Cartesian coordinate system. Now, if AB plus BC equal to S, that is, if the sum of any two sides greater than S, if the sum of, I have written on the board AB plus BC greater than SC, and we can write this in other 2 ways, that is AB plus SC greater than BC or BC plus SC greater than M. If that is, if the sum of any 2 sides is greater than the third, then we can draw a triangle with these 3 points. But if the sum of any 2 sides is equal to the third, or less than equal or less, that is, if the sum of any 2 sides equal to the third or less than, then we can't draw the triangle with these 3 vertices. Now, when to determine the triangle is equilateral or isosceles or scalene or right angle triangle. Number 1, equilateral triangle. Equilateral triangle, firstly we have to find AB equal to what? BC equal to what? SC equal to what? First we have to find. How can we determine AB? We can find the length of AB by the formula square root of x1 minus x2 whole square plus y1 minus y2 whole square. And in the same way, we can find BC and SC. If AB equal to BC equal to SC, if AB equal to BC equal to SC, then the triangle formed by these 3 points will be equilateral. But if any 2 sides are equal, that is either AB equal to SC or AB equal to BC or SC equal to BC. If any one of 3 is true, then we can say the triangle is an isosceles triangle. That is, if any two sides are equal, then the triangle is said to be isosceles. Now, scaling triangle. Scaling triangle, if three sides are unequal, that is AB not equal to BC is not equal to SC. Then the triangle ABC will be a scaling triangle. So now we can say right angle triangle. In the case of right angle triangle, so right angle triangle যদি if AB, BC and SC if AB, BC and SC satisfy the Pythagoras theorem. Pythagoras theorem, that is AB square plus BC square equal to SC square. Then in this case, angle ABC equal to 90 degree. 90 degree. If AB square plus BC square equal to AC square, then the angle ABC will be a right angle. So the Pythagoras theorem is satisfied. In this case, we can say the triangle ABC is a right angle triangle. Now, students, now if we can we know, dear students, we know a quadrilateral is formed by 4 points. The 4 points are A, x1, x1, y1, B, x2, y2, C, x3, y3, and D, x4 and y4. Firstly, we have to find that is firstly we have to find AB, BC, CD, and AD. Firstly, we have to determine AB, BC, CD, and AD, and diagonal SC equal to and diagonal PD equal to 1. Now, if AB, BC, CD, and AD are equal to one another, that is, if 4 sides of the quadrilateral are equal and their diagonals are also equal, that is, 4 sides are equal and their diagonals are also equal, then we can say that quadrilateral will be a square. We can also determine in other way. That is A, B, C, D. AB square plus BC square equal to SC square. That is, if the Pythagoras theorem is satisfied, then we can say the triangle ABC is a right angle triangle. And that is sorry, if AB square plus BC square equal to AC square, then we can say ABC is a square. But if AB equal to BC equal to CD equal to AD and diagonal AC is not equal to B. That is, if four sides are equal but their diagonals are unequal, then we can say the quadrilateral is a rhombus. And we can also find if AB square AB square plus AC square AB square plus BC square is not equal to AC square. That is, the Pythagoras theorem is not satisfied. Then we can say ABCD is a rhombus. That is, if four sides are AB square plus BC square is not equal to AC square, that is, this quadrilateral is a rhombus. Now, I want to say when these four points will be the vertices of a parallelogram or a rectangle. If A, B, C, D, A, B, C, D, if is equal to and theta, if the opposite sides, if the opposite sides are equal, any two opposite sides, AB and CD are two opposite sides, then AB, BC are two opposite sides. That is, if any two opposite sides in a quadrilateral are equal and their diagonals are also equal. That is, AB equal to CD and AD equal to this. Opposite sides are equal and their diagonals SC and BD are also equal. Then we can say this quadrilateral is a rectangle. We can also say if it is right angle, that is if AB square plus BC square equal to SC square, then angle ABC. If AB square plus BC square equal to SC square, then angle ABC is a right angle or 90 degree. So in this case, if opposite sides are equal and this Pythagoras theorem is satisfied, then the quadrilateral ABCD will be a rectangle. So I have discussed two ways to determine a rectangle. But if opposite sides, these two opposite sides or those two opposite sides are not are equal. Opposite sides equal. If these two opposite sides or those two opposite sides are equal, but their diagonals are not equal. Opposite sides are equal, but diagonals are not equal. Then we can say this quadrilateral is a parallelogram. Or if opposite sides are equal, but the Pythagoras theorem is not satisfied, then we can also say the quadrilateral is a parallelogram. So students, I hope you have understood. In exercise 11.1, in exercise 11.1, the distance between 2 points is discussed, and all problems related to 11.1 can be solved by this formula. So students, please do the problems of exercise 11.1. Now I am going to discuss about the formulae in exercise 11.2. 11.2. In the exercise 11.2, it is discussed for finding the area of a triangular region or a triangular region or pentagonal region, and so on. If 4 points are given, students, if these 3 points are given, if these 3 points are given, that is, if the uh, points are the vertices of a triangle. Let us assume these 3 points are the vertices of a triangle. Then, how can we determine the area of the triangular region ABC? That is area number 11.2. That is area of triangular equal to x1 by x2 by 2 x3 by k and x1 equal to x1 by 2 x2 by 3 by, that is positive. This will be positive. This will be positive. x1 y2 plus x2 y3 plus x3 y1 within first bracket minus x1 x2 y1 plus x3 y2 plus x1 y3 square units. Correct. So we can uh, if the vertices of a triangle are given, then we can find the area of the triangular region ABC by this formula. That is half. You have to write half modulus side x1 y1 abscissa ordinate of each point. That is x1 y1 at the coordinates of the first point, x2 y2 second point, x3 y3 third point, and first point coordinates of the first point will be repeated in the last. Now x1 y, that is from up to bottom, x1 y2 x1 y2 x2 y3 x3 y1, আর যখন from bottom to up হয় তখন নেগেটিভ হবে, that is x2 y1 x3 y2 x1 y2 will be negative. This is a formula. We can I want to make you understand the another formula. This is 3 points. Now a b equal to small c, bc equal to small a, and sc equal to small b. Now s equal to a plus b plus c by 2. That is S is the semi perimeter. Length of AB is C, length of BC A, length of SC small b. Small b, that is A, B, C. ABC. Students, the points should be taken in the anti-clockwise direction. Remember, dear students, remember when you want to find the area of a triangular region or tetragonal region or pentagonal region and so on. Remember, you are to taken the points in the anti-clockwise direction. Anti-clockwise direction, that is A. This is anti-clockwise direction. Then area of triangle. Then area of triangle ABC equal to square root of S into S minus A, S minus B, and S minus. Friends, that is, we can also find the area by this rule. ABC, triangle ABC equal to square root of S into S minus C into S minus C into S minus C, where ABC are the lengths of three sides of the triangle, and S is the semi perimeter of the triangle. Now, if 4 points are the vertices of a quadrilateral x4 y4, the area of the tetragonal region equal to half x1 y1 x2 y2 x8 y10 x4 y4, and first point will be repeated. First point will be repeated, and this will be positive. In this case, the first coordinates has been repeated. Equal to half second bracket x1 y2 plus x2 y3 plus x3 y4 plus x4 y1 minus x plus this two x2 y1 y1 plus x3 y2 plus x4 and x1 y4 and second bracket that's squared in square that is we can also find the area of a pentagonal region in this way and so on. Remember the coordinates of the first point will be written first in every case. So students, in the exercise 11.2, all problems are related to this formula. Time is very short, so you are to solve these problems with this formula. Now I am going to discuss about the slope of a straight line. Slope, and we want to know what is slope of a straight line. Slope and slope. It is discussed about slope in the exercise 11.